Let's look at one more example of a problem of a object that's sitting on a slanted ramp. Okay, this one actually has a pulley involved as well. Okay, and so we're going to have some strain and some tension involved there, along with the other forces that we have. Okay, let's start off by drawing a force diagram or a free body diagram for each of my two objects. Okay, first I have the mass on the end of the string here. And for that one, we're going to have the force of gravity, or the weight, pulling down. And then we've got the tension of the string pulling up. Now, I only have one string here, so I'm going to only label one tension. I don't need to identify it as being a separate string or anything. So I have one tension involved in my problem. So we have that, and we know that we can calculate the weight of my brass mass here. Okay, it says that the brass mass hanging on the left side has a mass of 200 grams. So I can get the weight by taking 200 grams, which is the same thing as 0.200 kilograms, and multiplying it times negative 9.81. So that will give me negative 1.962. So negative 1.962, and yes, it should be negative because it's going down. Okay, now if the only other force on my brass mass here is the string pulling up, or the tension, that means that the tension has to balance the force of gravity pulling down, and so the tension will also be 1.962, but it'll be positive because it's going upwards. Okay, let's draw the force diagram on the block now. Okay, we've got, of course, the force of gravity pulling down, or the weight of the brick. We've got the normal force, which pushes up in this direction, obviously perpendicular to the ramp. We've got the tension, which pulls up this way. Okay, tension is pulling in the direction of the brick. And now here we actually have to make a little bit of a guess, because I'm going to assume that there's got to be some friction here, unless these forces are balanced perfectly, which is a possibility. But I would guess that there's probably some friction here. Now, there's two possibilities. It could be that the brick is heavy enough that it's going to outweigh this mass here, which means that the brick wants to slide down this way, so friction is going to be pushing up, which is going to be my assumption. The other possibility is that this mass has more of an effect than the mass of the brick sliding down, which means that this mass, the force this way, will be imbalanced and the brick wants to slide up. If that's the case, friction will be going down in this direction. Okay, really you just make a guess to start with. Since the mass of the brick is so much bigger than the mass of this brass guy here, then I'm going to assume that this one's bigger. But in the end, the math will come out and tell you, depending on whether it's positive or negative, will help you know which direction the brick is actually going to slide in. Okay. We can find, of course, we know that the tension will be the same as it was because it's the same string. That means it has to have the same tension. So 1.962 at this angle right here. It tells me that the angle is 45 degrees. Okay, so let me go ahead and write that into my picture here. 45 degrees, which conveniently means that this one up here is also 45. But then we'll go ahead and we can also find the force of gravity, which is the weight, of course. So that's 2.8 kilograms. So 2.8 kilograms times 9.81. Of course, it's going down, so it'll be negative. So 27.468 will be that one right there. And so now all I need to find is the normal force and the frictional force. Okay. In order to do those, I'm going to have to do the little trick of tilting my axis. Okay, so as you have probably guessed, since the angle here is 45, then I'm going to want to take my whole axis and tilt it to the right 45 degrees. Okay, which means that this is going to be my new y-axis, and this is going to be my new x-axis. Now, you're welcome to work from it from here if you want. You know that this angle will be 45 because that's how far you have tilted your axis. Okay, if you're more comfortable redrawing the axis, that's fine too. I'm going to go ahead and do that. Okay, so y and x. The normal force is straight up along the positive y-axis there. So here's my normal force, or the force of the ramp, right? Then these two forces, both tension and friction, go directly along the x-axis there. Okay. Now tension doesn't have to be along the x-axis for every single problem you ever do, but in this case the rope is parallel to the surface. If my rope was pulling up this way, then that would be a totally different story. My tension would be up here, meaning it would be in some other direction. Okay, but in this case the tension is pulling directly the same level as the ramp there, and so that is parallel. And then we've got the force of gravity, which won't be pulling down anymore because I've rotated everything 45 degrees, which means the force of gravity is right there at 45 degrees. Okay, so now I can write my equations. For the x component, I have the tension plus the force of friction plus the force of gravity, the x component, and those should add together to give me 0. And in the y direction, I'll have the normal force plus the force of gravity in the y direction, and those should add together to give me 0. Okay, so I obviously already have the tension. I should be able to get the components for the force of gravity. Okay, if you're okay with doing it there, that's fine. If you need a little more space, go ahead and draw the force of gravity over here, right? There's your y component. There's your x component. We know the force of gravity is 27.468. Okay, and so now you should be able to get the x and y components for that. So we know that these angles are both 45, since this is a right angle. So then we can just use 27.468 sine 45. And sine is the opposite side, so opposite from my angle. And so that gives me 19.42. So this is 19.422, right? 423. Okay, and since it's isosceles, this one will also be 19.423. This one will be negative because it's going down, and that one will be positive because it's going to the right. Okay, so now let's take those and let's put it into our equations. Okay, we know the tension is 1.962, and that is to the left, so negative 1.962 plus the force of friction is equal to the force of gravity in the x direction, plus the force of gravity in the x direction, which was 19.423. So then I'll add those two together and move them to the other side. So that will mean negative 1.962 plus 19.422, so 17.46. So the force of friction will be negative 17.46, right? Because after I add them and it's positive, I got to subtract it to the other side. So negative 17.46 newtons. Okay, which makes sense because it's going to the left. And then I've got the y components here, which I don't know the normal force, but I just found out that the force of gravity in the y direction is negative 19.423, which then means that the normal force is positive 19.423 newtons. And there is my answer. And so now I know all the forces on my brick. And that's that problem. Good luck with your homework.